Let's wait for a minute. Okay, so once I increase the distance of the object from here to here, as I move this object from here to here, one thing is it will become dimmer, so intensity will go down. Okay, there is one more thing that's happening. Okay, as the thing goes far away, now the light will come like this. So what is the difference between this first case and the second case? First case, these are the two light rays that are entering the eye. The second case, when the object is moving far away, these are the two light rays. So one effect is the intensity of the light that's entering the eye has gone down. It might become a little bit dimmer. Okay. Other than that, is there any other effect that's happening when the object is moving far away? Students are still joining. Let's wait for a minute. If you know the answer, you can tell. As the object is moving far away, one thing is it will become a little bit dimmer because the amount of light entering the eye from the object will go down a little bit. It will actually go down as 1 by r square.
So the curvature will be less, sir.
Curvature of what? Okay, the lens, eye lens. Yeah,
Yes, sir.
that's fine. Other than that, what about this angle and this angle? Is it same?
Decrease, sir. It will decrease.
Yeah. So basically, the thing is, as the object distance increases, or you can say u increases, the angle, which we call it angle theta, okay, it also decreases. Okay, so this will give me a sense of distance of the object. So I can figure out whether the object is near or far by using this information that the angle is small. Okay, so this is possible if the eye is on the same side. Now two eyes, not just one. Advantage. Okay, it was a wider field of view. Okay, charge is going down. Okay, so start one eye, you lose the information of the depth. Okay, so you can close one of your eyes and try to. But since you already know standard objects are far away, maybe it will not be that clear. But if you go to a new place, okay, and figure out, just see the things with one eye, you're not able to judge the distance of the object. But once you open the other eye, you see the thing with two eyes, then you can sense how far the object is from you. Okay. So this information is coming because with two eyes, you can also sense the angle made by the object with a pair of eyes. So that's what is given this. Why do you have two eyes for vision of just one? So in some sense, we have a 3D view of the world. We have the information of the distance of the object. We have two eyes. And one more thing he's saying, Some animals will have two eyes, not on the same side, but on the opposite sides. Okay. Humans cannot see what is there behind you unless you turn your head. Okay. But some animals can have one eye in the front, other eye in the back, so you can see all wrong. Okay. But so if the eye, these animals have got one eye in the front, one eye in the back, you don't have the information of the depth of the distance of the object. Okay. So that thing they will lose. Another thing is saying is just close one eye and try to see a wide area. The amount of region or the angle of view will be 150 degrees. 180 degrees is the straight line. If eye is like this, okay, we can see objects in the front. You can see all the objects in the front. Then the field of view will be 180 degrees. This is 180, right? Okay, but it's not exactly 180. It's a little bit less than that. You can see from here to here, 150 degrees. So whatever is there in this angle, the eye can see. This is a single eye. Okay. If you open both eyes, then the field of view increases. To 180 degrees. You can see almost everything is there is in the front. But some animals will have one eye on the front of the head and the other in the back, so that they can see 360 degrees. So this is the head. One eye is here. Okay. Eye one. Second eye is in the back. Eye two. So this is for animal, not for humans. Okay. So they can see all wrong. 360 degrees. But for human, both eyes on the front side only. Okay. So it can see up to maximum 180 degrees. You can see only objects in the front side. But if the advantage of having both eyes in the front side is we can get the sense of distance of the object because the far away object will make a smaller angle. So you get the information of the distance of the object. So this is the advantage of having both eyes on the same side. Get the depth of the object. Use human eye. Other things I'll do next time. So we'll stop up to here. So any questions?
No, sir.
What about light chapter, the first chapter? Periodic test is coming, right? When is the physics test or science test? School is opening on 10th. Are they informed?
Yes,
Yes,
sir.
sir.
And when is the science test?
So I think it's on 21st.
21st of June, sir.
Oh. Okay. So for two chapters I are given, light and electricity. So prepare well, solve as many problems as possible, not just creative questions. That is all numerical questions. Go and CBSE. Okay. More you solve problems, the more you become clear for you. So the I chapter, there is not much numerical, except for this one part. They will ask you to find the focal length of the specs. They'll give the defect that the human eye cannot see. Normal eyes can see up to 20 centimeters. This sort of a defective eye will see up to only from 50 centimeters. So to correct that eye, what should be the focal length of the spectacles? That's sort of a question they will ask. Numerical question. So in this chapter, numerical is not only that type. Other questions will be theoretical questions. This particular chapter. Take one function of iris of human eye. Actually, there is only one function, right? Basically, it shuts the eye to reduce the intensity of light. If the object is too bright, the eye will get damaged, right? So it has to reduce the amount of light entering the eye. So just uh, reduce the opening of the eye, which is the pupil. So it's a dark membrane which controls the size of the pupil. So if the pupil is small, the amount of light entering the eye is small. This opening is the pupil. Okay, this is iris. So if the object is too bright, this iris will close a little bit so that the opening is small. The amount of light entering the eye will be small or less. Otherwise, the eye will get damaged. State bound function of the obviously without lens you cannot see the object. It focuses the light. Not a good question. Okay, basically you use the image of the object on the retina. Define the term power of accommodation. Right, the modification of curvature of the eye lens, which enables us to figure out this. Power of modification is basically the ability of the human eye to adjust its focal length. Modification in curvature of eye lens that enables us to figure right the modification. Okay, ability of human eye to adjust the focal length is called power of accommodation. Ability muscles modify the curvature to some extent. Basically, curvature is basically focal is related to R1 and R2. R1 and R2 the radius of curvature of both the sides. The curvature changing is radius is changing, so focal will change. So all these are theoretical questions. So this basically the functionality of the eye. The first eye will hit the cornea. So that is the first thing. This one, outermost part of the eye. The eye first will enter the cornea. Whenever there is a change of medium, this is air, this is some material, right? So obviously there is a change in diffractive index, the light will get bent here. Next will pass to this aqueous humor. I will enter the lens. I will form the image on the retina. So this is the sequence in which the image is getting formed. And after that, once it forms the retina, the light signal will get converted to electrical signal, and the electrical signal will transfer to the brain. When bright light enters the eye, most of the diffraction occurs in the outer surface of cornea. So crystalline merely provides the minor adjustment of the focal from NCRT. Okay. Pupil regulates the amount of light. Actually, it should be iris. Okay. At retina, light signals are getting activated, and then generate electrical signals. These signals are going to brain via the optic nerves. Okay. When you interpret these signals, brain will invert the image. Because image of a convex lens is always inverted. It's a real image. So brain will do that inversion, figure out is the whatever is the image in the front. Same question. Why the image distance of the human eye does not change? Because it's basically the size of the eyeball. The distance between the eye lens and the retina. Obviously, once the human is fixed, eyeball is fixed. Okay, it cannot change. It can change it. Actually, it should not change too much from person to person also. Okay. The second part of the question. Does not answer. I'm going to answer the second part. Explain why the image distance does not change. Because the lens, distance between the lens and the retina is fixed. That's why it's not streaming. It's not open. Okay, so go do this question and don't look at the answer. First, you get your answer and then check. Function of the following parts. Cornea is the first part where the light is entering, and there will refraction happen here because there is change of medium. Iris is for controlling the intensity of the light. The object is brightness signal at the opening of the eye lens. Pupil is just the open part of the eye lens. Whichever part is the open part, that is pupil. Okay. If you look at the mirror, you can actually see the pupil. Pupil will be in dark color, and you can also see the iris of your eye looking at the mirror, plain mirror. It's actually not correct. Pupil is just the open part of the eye. Iris is the one which controls the amount of light entering the eye. Okay, 5 mark questions. That will be basically specs questions. Prism is also there. Previously, we have learned rectangular slab. In this chapter, we learned prism, triangular prism. See, a person cannot read newspaper based nearer than 50 centimeters. Normal eye, we can see up to 25 centimeters, right? So this person has got a problem from 25 centimeters to 50 centimeters. So name the defect of the machine is suffering from. Draw the diagram to illustrate the defect. This is a possible process. And draw the diagram how the defect will be corrected. So this is perpendicular specs, and you have to find the focal length of the specs. So this is numerical will come in this chapter, which we'll do later. So we'll close now, unless you have some questions. Any doubts, questions? So shall we close?
Sir.
Yeah. Okay. See you next class. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you, sir.
Thank you, sir.